Okay, in chassis ground, it is a ground collection point. Means that several components which needs to be grounded, their connections are connected at the chassis, and then it follows the flow of the ground circuit. Then, so these are the ground traces on the circuit boards, and these are the ground leads on the motors and solenoids. Means the wires which are coming out of the motors and solenoids. And then the case of the equipment, if the case is made of metal, that can act as a ground collection point as well. Okay, and it actually prevents current from circulating into the chassis. Okay, which can be caused by even the static charges, and can also cause a mild shock upon touching that, if there is an accumulation of that. So in the schematic diagram, if you see there can be components inside it, and this thick lining around them is the grounding, the ground trace. This is the ground trace of a metal, for mostly most likely the copper, and these small lines are the collections, are the connections, and then whichever component needs to be grounded is grounded through this thick ground trace surrounding it. So this one is connected with this thick ground trace is connected with the metal shield around the power supply, which is then connected to the third prong of the wall socket, which is connected to the earth or grounding of the building actually. So in this way, all these small components in on a PCB uh, are connected to the actual earth or ground of the building through this trace, ground trace, and this chassis. This metal should we can call this trace, this setup as a um, uh, chassis chassis ground. Okay, in the next circuit diagram, on the photograph of a circuit, we can see there is a PCB where this is supposed to be all these components inside. This circuit is drawn, and this thick tracing on surrounding of all these components is the ground trace actually. Okay, this ground collection point also for all the components. Okay, in the next one, there's another PCB. It's a different type of tracing, but again it is thick, and then it is also running in the center also. So these are two sections of the circuits drawn, one on one side and on the other side, and for them this ground trace is provided for all the components which require to be grounded. Another example, this is a larger one. It has many different sections, and all these sections have a ground trace around it. Okay, you can see in this one and this one, all the thick lines which are in the form of rectangles are ground traces in all of these circuit sections. So whichever component provides, whichever component needs a grounding connection, that can be connected to these ground traces. And this is a ground testing pin. It is provided on the circuit board also, because it's not always convenient to test every component, because the components are so densely packed and sometimes covered with the shielding. So grounding point is the ground testing pin is provided separately on the circuit board at a convenient location where the testing can be performed. And this in this particular figure, this is a chassis ground in which the body, this is the metallic housing of or casing of an equipment that has a ground connection. If you see that there is a protective ground symbol also. So this is a chassis ground actually. This power plug is connected with uh, the body or casing of the component, and this symbol indicates that this connector is going to ground. Okay, now there is another type of grounding which is called as logic ground. Logic ground is different. It is not the zero voltage type of ground, it is a different one. It is a slightly different potential than the chassis ground. Chassis ground is eventually going to the ground circuit, but this one is different. So it is slightly different potential than the chassis ground. Digital logic ground is the reference terminal of the power supply for the digital logic. Okay, for most cases it is simply the negative terminal of the power supply. Like in this case, we can see this is the power plug, this is the power supply, this is metal shielding like the in the example before. This is a chassis ground, you can see that it's written there, and these are the components. You can consider these are the ICs. So this is the on the top is the positive 5 volts, and the bottom connections are going to the negative terminal. So this negative part is the logic ground. This is not the chassis ground or earth ground, this is the logic ground, which has a potential. This is not 0 volt potential, it is the negative terminal of the battery or the power supply. Okay, this type of grounding is different from the ones that we studied in previous slides. In this, our ground signal is a specific signal is provided, which is considered as a ground. It is a reference point from which other signals are made. What does it mean is, let us see, we have a couple of signals running through. For example, this is one signal, and then there is another signal, this one. These are in our circuit, but what is the level of these? Means on the means how do we measure them? So we measure them by considering a reference. Like this is voltage. So this is, we can consider that this is 0 volt or ground. This is ground. So we can measure from here and from here. This is the level of these signals. But in when signal ground is used, then this one is not done. So this is not the level that we measure. We introduce another signal in there. So we introduce another signal like this signal. I will highlight it with this one. So this is another signal which is introduced into the system. Now the level of these signals which are already running in the circuit will be measured from this signal. This one is signal ground. Okay, so it is important in the type of measurements which are very sensitive and we need very accurate readings. So, it is a clean ground or ground connection without injected noise. Accurate measurements of very small changes in voltage levels, okay, such as those in the medical equipment. We need very small voltage changes to be measured, like in the electrical activity of the heart, or if you are studying brain waves. So very subtle changes in the voltage levels are very important. So in such equipment where these small changes are to be measured accurately, like in the medical equipment, this type of grounding is provided.